Hello and welcome to Going Native number 47. I'm Steve Carroll. I'm the dev manager for Visual C++.
I'm Gabriel Destrace, developer on the C++ team.
And man about C++, just in general. Today we're here to talk to you about libraries again. New and exciting features inside Update 2. All right, and welcome to Going Native. We have two folks here today. We have Eric Mittelette, who is a new PM on the libraries team, and an old favorite, Stefan T. Lavoade, our STL maintainer and our STL named person. So Eric, why don't you introduce yourself since you're new here?
Well, I'm pretty new in the team. I joined the Visual C++ team in last July. I come from the field, as you can hear with my strong accent. I was in Microsoft France in '98, and I am a C++ lover since the beginning, I think, early '90. I was at this time consultant and trainer about MFC, you know?
Got it. One day, not realizing MFC would be the thing you own. Okay, cool. And Stefan, you're famous on the internet.
Yes.
All right, cool. Yes, on the internet, no one knows that you're a dog. I actually used to think you were a cat, but now we have video proof that it's not the truth. All right, today we're here to talk about some major milestones that we hit in our STL implementation. Stefan, tell us about what the big milestone we hit was.
So we are CS+17 so far feature complete in the STL, meaning we've implemented every proposal that's been voted into the current CS+17 working paper.
Great, and I'm guessing everything that we're going to show today, if you pull down either the CTPs that we've released of Dev 14 Update 2, or if you pull down our brand new NuGet acquisition experience to grab a nightly build, you should be able to try out all of these today, right?
Yes,
Okay.
we believe all of it got into Update 2 CDP.
Okay.
Yeah, but you can also test it today with the web compiler we updated last week.
Right. In fact, we updated that as soon as the blog post went live.
Yeah, exactly.
Right. So there's almost like an embarrassment of different ways that you can actually try this out for yourself. All right, so up to the minute C++17. So that will last us through to the end of the month when there's another meeting in Jacksonville.
Yes, then they're going to vote in more stuff, and we won't have that. But for the moment, we're complete.
Okay, but we'll make you finish it before you get back on the plane.
Code faster, monkey.
All right. Yes. All right. So let's go through some of what the actual additions are. What does this mean to the average developer on the street who wants to go and use their libraries?
Right. Well, there's 10 different features that we've added between RTM and Update 2, Update 2. And we can go through them in sort of increasing difficulty order if you want. I can bring them up on my laptop.
All right, great.
So here I've got the blog post that we wrote because I can't remember all the stuff that we implemented. And all the rows in green are the stuff we implemented. And while I wrote most of these features, our other STL devs, Billy O'Neill and Steve Wisniewski, implemented a few. So it's not just me here.
No, there's some other new folks that have joined the team.
New hires. So the simplest feature is as const. And this here, I could show you the standard, or I could also show you just our implementation. This is literally a one-line helper function. So if you've ever had an object and you're like, man, I really want to pass this to some other function, but I want to pass it as a const reference to whatever, instead of static casting it or whatever, now you can just pass it to stood as const. That will take an arbitrary tref and return it as a const tref. So if something you're passing cares about overload resolution based on constness, that could be helpful. For example, maybe you have some modifiable vector of int, v, and it's filled with stuff, and later you're passing v of 0 to a function. That's going to be a modifiable ref. But then if you say, as const, v0, now that's a constant ref, and whatever you're giving it to is not allowed to modify it. So simple little function, but its design is actually not completely obvious because you don't want to pass temporaries. It would be very bad if you gave a temporary to asConst and it happily returned a const L value reference to it, and then the temporary evaporated. So the standard deletes an R value overload, which somebody just writing this from scratch may not have thought of. So we've got that as well.
Awesome.
So in slightly increased complexity, Billy implemented Howard Hinnan's chrono helper functions that were added in CS+17, the floor, ceiling, round, and absolute value. Round in particular might be useful. So for example, if you've got a duration, chrono duration, and so say you start with milliseconds. So milliseconds, ms, and this is equal to something. And you're like, okay, I want this as whole seconds. Well, previously in CS+11, you would have said duration cast to seconds because this loses precision. You need to do it explicitly, ms. And what duration cast did is it truncated. So 3.14 milliseconds, or let's see, 3,141 milliseconds would become exactly 3 seconds. You would truncate. And similarly, with negative values, you would truncate off any fractional part. Sometimes you don't want that. What if you want to round 3,900 milliseconds to 4 whole seconds? Or negative 3,900 seconds to negative 4 whole seconds. Now you can simply say round, and you still need to tell it the destination type that you want. And this will do the type conversion, precision conversion, and also do rounding. And you can get floor to negative infinity, ceil to positive infinity, or take the absolute value. Just nice little quality of life functions if you're working with the CS+11 chrono utilities, which are even cooler now that we have user-defined literals. So you can say, you know, this thread sleep for 15 ms if you want.
Right,
And
really
that's something we shipped in
increases,
RTM.
like legibility of code.
Yeah, rather than working with like just raw doubles and saying, okay, this double means milliseconds now. Oh wait, now this double means seconds. It's sort of a units library, but just for times. So those are the chrono utility functions. Next up is, it seems like a complicated thing, but it actually is sort of a hello world thing that people run into when they use a std function. So we implemented, working with the compiler team, expression SFINAE in std result of and std function. So what happened in the compiler, as you've been blogging about, is that the compiler has partial support for expression SFINAE in update 1. And in update 2, that was further enhanced, and we are now finally able to use it in the STL. And in particular, std function is now required to use expression SFINAE in CS+14. So while the compiler support is still partial, the STL support is 100% rock solid, verified by exhaustive tests. And what this means is, if you're a metaprogrammer, you're already drooling over this. But even if you just sort of use std function for fun, this can come up. So for example, say you're writing meow, here is some user function. And you're like, okay, I want to take some callback, so I'm going to take a std function, and its signature is going to be something like this. Maybe I take an int, and I multiply it by 2 or something, f. And this could be passed by const or f, whatever, it doesn't matter. And maybe you want to overload your thing with a different signature. Like here, this one would take 2 ints and add or multiply them or whatever. Okay, and call that g. So in CS+14 you can write this, but in CS+11 it was ambiguous. So if I gave it a lambda, like int x, int y, that would return x plus y, like this. A human looks at this code and says, hey, I gave you a lambda that takes 2 ints and then returns an int. And of course I want you to call, this one here, this meow, that takes a std function that takes 2 ints and returns an int. And CS+11 and Visual Studio 2015 RTM and Update 1 would say, oh, that's ambiguous. I don't know what to do here. And in Update 2 and CS+14, it just works. And the reason why is because std function has a constructor that now exists only when you could possibly construct the std function from whatever lambda or function object you're giving it. So that needs very advanced metaprogramming to define, but once std function behaves like that, then you can just use it without thinking about it. Similar enhancements were applied to std pair and std tuple previously. So you may not be interested in expression SFINAE, but expression SFINAE is interested in you. That's how I'd put it.
Should we define that for folks?
Yeah, SFINAE means substitution failure is not an error. It's this metaprogramming thing. You can go read about it on Wikipedia. Continuing on this sort of journey of SFINAE, so what this looks like in the standard is really weird. Essentially what std tuple is trying to do is it's trying to do things that the core language is not really set up to do yet. Mark constructors as conditionally explicit. And we can do it in the library with enough metaprogramming, so that's what we've done. Here it looks like in the standard, whenever you see capital explicit, it means that the thing is maybe implicit or not. And in the implementation, if I bring up tuple, we've got a whole bunch of metaprogramming at the top now. This is all new if you ever diff our headers. And then by the time you get to tuple's actual definition, and IntelliSense, I believe, will show you all of this spam. I'm sorry, but I'm not sorry because the standard's making me. Yeah, but this is what it will show like is every constructor the tuple has, almost every constructor, is now overloaded twice. One that's plain and one that is explicit. And what this achieves for you is, imagine you've got a function, say I return a tuple of, say, string, int and int, and again my function is called meow. and I want to return something like, and here's what I would have had to write before. Return make tuple of cat, and then 11, 22, like this. And I would have to say, okay, I need to make a tuple. Now, if I'm just constructing a tuple at local scope, like this, if I had a tuple of string int t, I can just brace construct it from whatever I want. I could say, dog 33, 44. But previously, if I had tried to, I would need a brace here. If I had tried to brace return a tuple in a function, it would have failed to compile because the standard had marked it as explicit. And the reason why is that for a single argument constructor, you don't always want that to be implicitly convertible. For example, you would not want a tuple of int to be implicitly convertible to a tuple of vector double. You want that to be explicit, but not implicit. And in CS+17, the standardization committee finally figured out how to do this with this conditional explicit sort of technology. So now what you can do is, if you've got this thing, you can say return and just put braces, and then put whatever you want there. You could say cat 11, 22, like this. And this will now compile in update 2. And the reason why is that tuples constructor is implicit if and only if each element is implicitly convertible.
I see.
And because const_char star is implicitly convertible to string, a tuple involving const_char star is now implicitly convertible. And this applies to the brace constructor as well.
So this is another kind of an example where the libraries now behave maybe like the way you expected them to in the, in the time, but so it's like more human-friendly.
Yeah, more intuitive, even though it requires decidedly non-human, inhuman metaprogramming to achieve.
Fortunately, we have a robot who implements the standard template library, so you
Error
don't have
does
to.
not compute.
Yes, yeah.
Yeah. Another feature that we implemented is variable templates for type traits, and this is actually something that I proposed for the library fundamentals TS, and then Alistair Meredith proposed to move into CS+17, and that was accepted at the last meeting. This actually uses a core language feature that I believe Gabriel had proposed that got into CS+14 for the core language. And now in CS+17, the standard library is going to take advantage of it. So what's a variable template for type trait? Well, you might have heard of the most popular or the best feature, in my opinion, in CS+11, where previously you would have, in a template, imagine, template, type name t. Previously, if you wanted to use decay, you'd have to say something like type name, decay of capital T, double colon type, and this was just hideous. In CS+11, we got alias templates, and in CS+14, yes, in CS+14, we got them in the standard library thanks to Walter Brown. Now you can simply say std decay underscore T of capital T, and this allows you to eliminate the type name double colon type. And we shipped these in VC 2013. Even though we didn't have most CS+14 features, this one was so important that we used the just implemented alias templates in the standard library. So variable templates are sort of related to this. Imagine that you had a template on type name t, and here you need to enable if. So you're like, okay, I'm going to enable if t condition. And maybe your condition is something like is integral of t double colon value. And then, return type, and then angle, and then whatever the function name is, meow. Okay, thanks. What type traits used to do back in TR1 and CS+11 is the ones that were property queries, like are you integral, are you const, they would have a static, now it's const_expr data member named value. That's either true or false. And you would need to access it by saying double colon value. Now with variable templates, just as the alias templates allowed us to get rid of the double colon type, variable templates for type traits allow us to get rid of the double colon value. So instead of this thing, we can say is integral underscore v, with the underscore v being a reminder, hey, I want the value out of this. And this thing is just a bool. It's a static const_expr bool that's equal to is integral of t double colon value. So convenient shorthand. It's not the biggest time saver in the world, but in sort of heavily nested code, it actually can be kind of nice because it avoids the need to have to match up double colon value all the way down here with the is integral or is floating point all the way up here.
The code is more readable.
Yeah, much more readable. And metaprogramming is always going to be a little eye-watering, but now it's going to be less thanks to the variable templates. And these are supported not only by C1XX but also Clang C2. So regardless of what actual CodeGen compiler you're using, you can use these variable templates for type traits.
It's only the IDE where you don't.
Yes, one limitation that we blogged about when we announced this is that the EDG compiler, which we use for IntelliSense, just due to the timings of check-ins, they weren't quite ready to enable this yet. So in update 2, even the release to web version, if you are looking at it through IntelliSense, we will pre-process away usage of variable templates in STL headers. So is integral underscore v, is same underscore v, they simply won't exist as far as IntelliSense is concerned. So you're going to see red squiggles. But you can still actually compile that code because we'll go through a different compiler, C1XX or Clang C2, for the actual code gen. And by update 3, IntelliSense will have caught up and you'll get all of this. But we felt that it would be better to ship this feature in 2 out of 3 front ends rather than just artificially hold it back. So hopefully users will understand. And finally, the other feature that I want to talk about was conjunction. This is something, again, that Bailey O'Neill had implemented. This was proposed by Jonathan Wakely, who works on libstud C++ for GCC. And what this is it's type traits for type traits. Like, there's no end to the type traits.
Type traits inception, okay.
Exactly, yes, we must go deeper. This was originally proposed, I think, as and underscore, but certain people in the committee thought that that was too complicated or too confusing because there's also a quasi-keyword named and. So it got renamed during the process of
Someone was working towards some sort of Schoolhouse Rock-based joke.
Yeah, conjunction, junction, there's just no end of the jokes. So now these things are called conjunction, disjunction, and negation. But what they are is and, or, and not for type traits. And we actually use this in some of the performance work we've been doing in Update 2. So part of the themes of Update 2 is, one, all these features, look at this stuff that we're shipping for free. And the other part is, hey, we're making the STL faster, which is awesome. And one of the optimizations that we're shipping involves metaprogramming that involves conjunction. This is useful if you need, it's not critical, but it actually is a pretty significant time saver when you're working with metaprogramming. So one of the things, and I know this is like a page of metaprogramming, but it's actually useful. One of the things that we did all the way back, I think as far as like 2005, maybe earlier, is std copy and anything going through the same code path, like say vector reallocation. By default, it needs to iterate over every element and assign it to the destination. But we know that there's a CRT function, memcopy or memmove, that can simply blast a whole chunk of bits from a source to destination faster than the core language can, because it's implemented with special assembly that's conditioned on processors, and it's super smart. And in the library, what we try to do is we use metaprogramming to notice when the inputs to std copy are something like int star writing to int star. In that case, we know they're not user-defined types, they're all raw pointers.
So it's safe.
Yeah, it's safe to call memcopy. Whereas if it's something like a list iterator or a pointer to some arbitrary user-defined type, or even like a std string, we know we need to use the general loop because we need to call copy constructors. We can't just blast bits from the source to destination. And originally, back in 2005 or whatever, this was restricted really only to scalars, meaning like ints, doubles, pointers as elements, things like that. If you even had like a struct point taking, containing int x and int y, we would look at that and be like, oh, that's some user-defined struct. I have no idea what it's doing. And we would use the general loop. But now that we've had type traits implemented in the compiler and they've been refined to the point where we can actually rely on their answers, we can now generalize this optimization. So in addition to implementing conjunction, Billy went and rewrote our internal machinery to detect when to activate this memmove optimization. So now we use is trivially copyable, is trivial from the compiler, and other metaprogramming to detect when it's okay to just blast bits from the source to the destination. And here is a natural use case where conjunction comes up. So we've got all these layers of metaprogramming. One of them is if we're just copying an element type to itself and it's a raw pointer, then we just ask the compiler, hey, is this thing trivially copyable? And trivially copyable is the type trait that says whether it's safe to memmove. And so there we just rely on the compiler to get it right. And this type trait was overhauled in 2015 to report accurate answers. But when we're copying elements of different types, we can actually sometimes activate this memmove optimization even when the types are different. For example, if the source is int and the destination is long, yeah, they're different types, but on our platforms, they're actually 32-bit integers. or actually if the source is int and the destination is unsigned int, that assignment is value modifying in the sense that a -1 value would become 2 to the 32 minus 1. But if you actually look at what the metal is doing, it's just copying bits from the source to destination, thanks to 2's complement. There's no actual representation change. And so because in the STL we want to make things, fast, we can actually say, okay, if all of the following are true, and that's when we say conjunction, if the size of the source is equal to the size of the destination, and they're both integral types, meaning not like even floating point or something, and various things about bool and they're not volatile, then all of the stars have aligned, and we have detected that we can now use memmove. And so we return true type, and then that goes and activates the right code path for us. And here conjunction was very convenient. We could have written this in the older form with double colon value and double colon value, so and so, but conjunction allows us to express it more tersely, and there's even throughput wins. One of the ways that conjunction is nice is when Jonathan Wakely designed this, he made it short circuit at compile time. So if conjunction notices that one of the first mentioned conditions is false, well, we know that false and stuff is always false. So it short circuits and doesn't evaluate, even at compile time, the remaining stuff. So although this is sort of shoving more code through the compiler, and in that respect it may slightly increase compile times, we can also short circuit some of that work. So it sort of has no effect on compile times, we hope. And we have data that shows that it has a major effect on run times. So we felt that adding more metaprogramming to achieve better performance from the generated code was worth it. And we're starting to use conjunction more and more throughout the STL.
You mentioned that this should qualitatively have some performance speedups. Did we measure this at all?
Yeah, we did do measurements, and if I can remember what Billy had found, the gains are most significant for small, like char or short size types. There still sometimes are improvements when you're copying things like int or long sized, but for the things that are like 1 byte or 2 bytes, it can be significant. So if you have like a struct that only contains an unsigned char, I believe the memmove optimization can give you 9.5 times the performance. Wow. And that's times, not percent. Just because memmove can blast whole chunks at a time rather than copy a byte, copy a byte, copy a byte.
And so just to be clear, so like people who recompile with the update 2 bits will get that for free.
Exactly. This is for free. Anytime that you give such types that are like structs that don't have copy constructors, and all that they contain are built-in types like chars and pointers, and you give them to the STL, either to std copy or to things like vector when it reallocates. We will, in optimized release mode, notice and just automatically use memmove. And we believe that this is a safe optimization whenever we activate it. So you'll just get a performance improvement for free just by recompiling. No action required or even possible on the user's part.
Awesome.
So yeah, that is all of the features that we added. We also did other performance improvements like the iostreams that I tweeted about that one. I don't think I've blogged about it. No, I can't remember. We haven't blogged about that yet. I'm going to write a blog post about it. But
spoil it!
Yes, spoiler, spoiler. So one of the things we did and this is a sort of long, sad story. Back in VC 2010, we picked up code. This is after the release of VC 2010, when we were working on 2012. We picked up code that promised to improve the accuracy of our floating point conversions, didn't really achieve that, and also was massively slower. So between VC 2010 and VC 2012, the performance of just parsing floating point with iostreams, which would look like if you had some stream and you said right shift float, where FLT is a float, or if you said stream, right shift into double, that attempts to parse a string like 3.141 into an actual float or double value. That got a lot slower between 2010 and 2012. We tried to fix it in 2013, fix didn't really work. For 2015, we did nothing because we kept trying to fix it and it would destabilize things. We actually, in 2015, we did at least manage to get more accuracy out of it. We kept getting bits wrong at the very end, like the least significant bits. 2015 got us like mostly correct, but at a 3x further cost and speed. So it's even slower in 2015, and I'm super sorry. So between update 1 and update 2, we finally got a chance to look into this issue. I finally figured out what was going wrong and how to fix it, and in fact, without breaking binary compatibility. So that fix got into update 2 and will be part of the final released version. And as a result, when you stream in, it could be from CN or from a F stream or whatever into a float or a double, we will now be massively faster to the tune of 17 to 19 times faster, not percent, times, over an order of magnitude. And we get all of the bits correct, even for the weird, bizarre subnormals, denormals that are like 10 to the negative 30. We get all of those bits correct because we're now just calling this CRT. And the CRT was overhauled in 2015 by James McNellis to get all of these things exactly correct through stir to D and stir to F.
Great.
And this is no action required on the user's part. In fact, they just need to run against the update 2 DLL. They don't even need to recompile their code. So that happens sort of for free.
That's excellent. So perf, you got simplicity of written code for less mistakes. It's full of win. Okay. So you can get the bits. We have update to CTP1 if you want to download the entire package of the update so that you can give us some feedback on that. You can also go to our web compiler. We'll have the link below. We've been updating that much more regularly to make sure that people can give us feedback on sort of intermediate bits as we continue to work towards update 2. And finally, we have a new mechanism, which is a NuGet server that we set up. So you can configure that to download sort of our nightly, or actually I think right now our weekly nightlies builds of the compiler as they're in progress. And we'd really appreciate your feedback. Put them below here, put them in Connect, put them in Reddit, we'll find them. But do reach out and tell us if you find any issues with these bits.
Please use them.
Yeah.